one of the most challenging parts of Lab 3 is being able to identify the zero phase point. So before I demonstrate how to do this, let's just take a chance to review the setup that we've already done. So first, we have the wiring configuration for the actual OctoPsi unit. So this is something where we're taking the waveform generator, we're splitting it because we have to have modulation on the fiber, which is how we're going to figure out the length. So one end of this cable is going to the laser transmitter, and the other end is going back up to the oscilloscope. And this is forming our timing reference point, right? So the signal on channel 1, this has not touched the fiber at all. This is the signal that we're going to use as our reference to figure out how long the fiber actually is. And then on channel 2 of the scope, we have the photoreceiver, which comes up here. Now this signal goes through the fiber, and as such, it's going to be delayed. So now that we've gone over the wiring, we're actually going to demonstrate how to identify what's the zero phase point. So the first thing you have to do is configure the time base on the oscilloscope. If you're using one reel alone, you should be reading 1 microsecond per division. So it'll say 1.00 right here on the screen. And you adjust that using the seconds per division control. Now, if you're using both reels together, 2.50 is you will need to use a value of 2.50 microseconds per division because the total time delay will not fit on the screen if you use one. So you're going to lose some resolution, but this is the only way you can actually see it. So now you're going to sweep the frequency control knob on the waveform generator. And as you notice, you're seeing many individual cycles on this screen. When you see those solid black bars, those are hundreds of cycles of the waveform. But now when I sweep it, you notice that there are 2 unique points on this screen where the waveform is kind of collapsing. And I'll place the marker here so you can see. Okay, so this is on channel 1. Channel 1 is on top, and that is the undelayed signal. And you can see where as I sweep that control, the waveform is kind of collapsing around that point. And on channel 2, you have the analogous point here. See how the wave is kind of collapsing around this one point. So obviously channel 2 is the delayed signal that has gone through the fiber. So what you're going to do is use the marker functions on the scope to measure the time delay between those 2 points.